Hey everybody, in today's tutorial we'll be discussing circles and area in chapter 13, and more specifically for section 2 we're going to be talking about perimeters of composite figures. Okay, so you want to be able to describe how to find the perimeter of a composite figure after this. And let's start by defining what is a composite figure. Well, that's our vocab word for the day. A composite figure, I might not be able to fit this in. Look up there, I did. A composite figure is made up of triangles, squares, rectangles, semicircles, and other two-dimensional figures. Here are two examples. So, for example, we have a square with a triangle, or a rectangle with a semicircle. It kind of looks like a silo. A lot of these examples can be used in real life. For example, when we're finding perimeter, we're trying to find the distance around something. So say, for example, someday you want to put a pool in at your house, okay? And your pool, you want it to look really cool, and you want to have this zero entry for it. So you're going to put steps going like this on your entryway into your pool. You need to find the perimeter of this shape, okay? Or maybe, for example, you're going to raise some horses or cows someday, and you need to put up some fencing, right? So here's going to be your pasture, and it might be something like this, where it's comprised of a triangle and a couple rectangles or something like that. You kind of get the idea. But the perimeter, remember, is the distance around something. Okay, so we're measuring this distance around different figures. Could be for a fence, could be for a pool. A lot of different examples. Maybe you're going to put in a garden. I can think of a lot that someday you might need to know. So in the first example here, we're just going to estimate the perimeter. So we're just going to get close. It wants us to estimate. So to do that, first we'll count the number of grid lengths that we have, those full square lengths. So for example, 1, 2, 3, 4, 5, 6. Looks like this distance is 6. And it looks like this distance is mirroring that, so that'd be 6. This outside length has 1, 2, 3, 4. Okay, and then it looks like the lengths right here are 1, 2, 1, 2. So I'll mark those as well. If I were to add up those numbers, I'd have 6 and 2 is 8. Plus this 8 would be 16. Plus 4 would be 20. So that's how they got this 20. For the full length squares. And then notice that these lengths right here are like that slant length or that diagonal length. And we're going to estimate diagonal lengths to be about 1.5 units. It's bigger than 1, but definitely smaller than 2. So we're going to estimate those lengths to be 1.5. So how many of those diagonal lengths do I have? 1, 2, 3, 4, 5, 6, 7, 8. So a total of 8 diagonal lengths. So to find my entire perimeter, I would add up my red. Again, the perimeter is the distance around. So for the red, the full length squares, I had a total of 20. Plus, I had a total of 8 diagonals, but each one of those diagonals represented 1.5, right? That's what we're estimating them to be. So if I were to take 8 times 1.5, that would give me 12. And then I'd take this 20 plus 12 to get a total perimeter of 32. And then since my units are not labeled, it doesn't say inches or centimeters or anything, remember, then you just put units. Okay, so 32 units around is the distance, the perimeter around this shape. All right, go ahead and try examples 1 and 2 now on your own. Please pause the video to see if you are doing this correct. All right, for this shape, let's count my full length squares. I got 1, 2, 3, 4, 5, 6, 7. So 7 on top and bottom. And then I have a bunch of diagonals. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I have 6 diagonals here. I'm going to write that in, and 6 diagonals on the back side, and then 7 holes. So my 6 and 6 diagonals, I'd have 12 total diagonals. Remember, each one of those is 1.5, so I need to multiply that by 1.5, and then I need to add to that my top and bottom. So 12 times that 1.5 should give you, oops, I put 1.2, I meant 1.5, should equal 18 for these diagonal lengths, plus 7 and 7 is 14. So 18 plus 14 should give you about, that's what that squiggly equal means, about 32 units. Okay, so that's kind of the way you go about finding or estimating the perimeter. For number 2, you should have come out to about 33.5 units. Okay, let me know if you have questions on either one of those, or phone a friend if you need to. All right, in the next example, we're going to do the same, except we need to remember what we learned last section, and that's finding the perimeter of a semicircle. Okay, you see here, we've got these 2 lengths of the side of the triangle, and then we have this semicircle region that we need to find that distance of for the perimeter as well. Okay, so the distance around the triangle part is 6, this distance, plus 8, this distance, which gives me a total of 14. And then the distance around the semicircle, remember that's half of the circumference of a circle, and the diameter is 10 feet. So let's remember our circumference formula for a circle is, pi times diameter. And in this case, I'm going to use 3.14 for pi, and I have to multiply that by my diameter, which is 10. So that would give me, if I'm multiplying by 10, I can just move my decimal 1 spot to the right, so 31.4. And that would be the circumference of the entire circle, remember, okay? So we only need to know the semicircle, so we can take 31.4 and lastly divide that by 2 to find the semicircle, which would give you 15.7 for this region on the outside. Okay, so if we take our 8 plus 6 plus 15.7, that should give us our perimeter. So adding those numbers up, you should arrive at 29.7, and we do have a label this time. It's feet. All right. And let's try something very similar for the next example. And here it's a little bit more lifelike. We're trying to find the perimeter of the track here. It's like for track and field, right? It's kind of like the one out at Bar-Built Complex. And it's made up of a rectangle and 2 semicircles. So here is a semicircle on the bottom. Here's another one. And then on the inside, we've got a rectangle here. Okay. So it says the semicircle ends of the track form a circle with a radius of 32 meters. find its circumference. Okay, so first, it's going to be helpful to find the circumference, because if you were to take this region and put it together with this region, it'd be a full circle. So then we can just use that for the two ends. So our circumference formula, circumference equals pi times, when we're given radius, remember the radius is 2 times the radius is the diameter, so 2 pi r. Okay, so 2 times 3.14 times, what is my radius? It is 32 meters. So when I multiply 2 times 3.14 times 32, I get about 200.96. So remember, that represents this region and this region, because if I were to put those two ends together, that would form this circle, and the circumference, remember, is the distance around the circle. So there's our two ends, and now we just need to add to that the inside, or the rectangle. Well, this portion is 100, so that would make this portion over here 100. So when I add that together, I'd get 200. 0.00. So if I add 100 plus 100 plus, I know the circumference of this circle is 200.96, I'll get a total of 400.96 meters. And remember, that was my perimeter, or the distance around the outside. And that makes sense, because if you know anything about track, 1 time around the track is called a 400. 2 times is an 800 race, right? 800 meter race. So maybe you're not in track, maybe you don't know that, but that makes a little bit more sense now. All right, go ahead and pause the video here for the last 2 on your own, and then we're done. Okay, for number 3, 24 plus 10 plus this semicircle region should give you about 74.82 centimeters. And for number 4, you should arrive at 41.12, 41 and 12 meters. And that's about right. We're getting close to the nearest hundredth. All right. If you had questions on either one of those two, please ask me, or as always, phone a friend. And that's all I got for perimeters of composite figures. I'll see you guys later.